How's it going, guys? Today in this video, we're going to be going over 10.3, Day 2, solving real-world problems with rational equations. So for this section, or for this part of the module, there's going to be two formulas you really need to know, and that's going to be this rates formula in this box over here, and this work time formula over here. So you have to have those memorized, and we're going to learn how to actually use them. So for examples 1, 2, and 3, we're told our rates is equal to time equals distance over rate. And if we have two objects that are going to be, they're going to have the same time traveling, the travel distance is going to be the same time, or in other words, time 1 equals time 2, then we can set the distance over rate of each object set equal to each other. It sounds a little confusing, it's a little weird to word out anyway. So let's look at number 1. We're going to go over that, and we're going to kind of see what I'm talking about. So we're told that a world-class cycling peloton, hope I'm saying that right, is traveling 120 miles, and then there's an average local cycling group that they're traveling only 70 miles. But they both reach their distance in the exact same time. So the time of the peloton group and the local group are equal to each other. The world-class cycling peloton, they're running 12 miles per hour faster than the local cycling group. So what we need to do is we need to find the rate of each cycling group. And when we say rate, we're talking about how fast they're going. They're miles per hour, the speed. Okay, so we're going to use this formula, this time equals distance over rate, and we're going to put this into this last formula over here. Since they both have the same exact time, we can set the distance over rate of each group set equal to each other. So for the world-class cycling peloton group, they're traveling a total of 120 miles, so their distance is 120, and their rate, we know they're going 12 miles faster than the local average cycling group. So let's say our local group, they have a distance of 70, and their rate is a rate of x. That means the peloton group, their speed or their rate is going to be 12 miles more than that, or x plus 12. From here, what we want to do is we want to find the least common denominator. So we're going to list out each individual factor that we see, x plus 12 and x, and our least common denominator. We're going to get that by multiplying each factor by the highest power that we see. And each one only has a power of 1 in the equation, so our LCD is x plus 12 times x. So now we take our LCD and we multiply each fraction with our LCD. Right from here is going to be very similar to what we did in the last video. Or I guess if you didn't watch the last video, the last module. So we have 120 over x plus 12 times our LCD of x plus 12 times x. And that's going to equal 70 over x times x plus 12 times x. So when you multiply any fraction with its LCD, you're going to get rid of the denominator. And that's what we're trying to do here. So this x plus 12 and this x plus 12 here, they cancel out. And we're left with 120x. And for the second side, or the other side of the equation, this x and that x both cancel out. And we're left with 70 times x plus 12. Okay? So now we need to distribute out that 70. And when we do, we should get 120x equals 70x. And 70 times 12 is 840. So plus 840. Now we're just going to be solving for x. So we minus the 70x over. And we get that 50x equals 840. Give myself a little more room. So when 50x equals 840, my x is going to be 16.8. And we said our x value is equal to the rate or the speed of the average local cycling group. So that tells me that my local group, they have a rate of 16.8 miles per hour. And then the peloton group, they're going 12 miles faster. They have a rate 12 more than the local group. So they're going 28.8 miles per hour. And that's our answer. We wanted to find the rate of each cycling group. The local group, their rate is going to be 16.8 miles per hour. And the peloton group has a rate of 28.8 miles per hour. Okay? So that's what we mean when we say we set each object's distance over rate set equal to each other. The times are the same, If they're traveling a certain distance at the same within the same time frame, we can set each object's distance over rate set equal to each other. And for number 2, we're going to go about it the same way. We're told a car is traveling 80 miles and a semi is traveling 55 miles, and they're both going to reach their destination in the exact same time. So their times are the same. So if their times are the same, we can set their distance over rate set equal to each other. And we're told the car's rate is 25 miles per hour faster than the semi's rate. So if the car is going 80 miles and the semi is going 55 miles, if the semi's rate or its speed is x, that means the car's rate or its speed is x plus 25. From here, we're going to figure out our LCD. And if you solve out your LCD, we should get x times x plus 25. Okay? I'm not going to spend too much time trying to find the LCD. That's for last video. This video, we're going to focus on just solving out real-world applications of these problems. So now we have our LCD. We're going to multiply each fraction with our LCD. So we have 80 all over x plus 25 times x plus 25. And that's going to equal 55 over x times x plus 25. And when we multiply any fraction with the LCD, we're going to get rid of the denominator. And that's what happens. The x plus 25's cancel out. The x cancels out. And we're left with 80x equals 55 times x plus 25. We're going to distribute out that 55. And we get 55x. And 55 times 25 gives us, let me double check, 1375. All right. So now we're going to add our x's together and we're going to solve for x. Minus 55x on both sides. And we get that 25x equals 1375. Or that x equals 55. 1375 divided by 25 is 55. And we said that our x value is equal to the semi's rate or the semi's mile per hour. So that means the semi is going 55 miles per hour, and the car, we're told, is going 25 miles or 25 more than the semi's rate. So 25 more than 55 is 80. So the car is going 80 miles per hour. Okay. And now let's go on to number 3. On number 3, we're told the passenger train travels 392 miles in the same time. That's the key word there, the same time that it takes a freight train to travel 322 miles. If the passenger train travels 20 miles per hour faster than the freight train, find the speed of each train. So the passenger train is going 20 miles per hour faster. So we're going to set up an equation here. We know that the passenger train is going a total of 392 miles. And we know the freight train is going 322 miles. That's the distances. That's going to be the numerator for each fraction. All right. So for the passenger train, we're told it goes 20 miles per hour faster than the freight train. So the freight train is x, its rate is x, and the passenger train, its rate is x plus 20. So now we need to find our LCD. And if you solved it out and you look for your LCD, you should get x times x plus 20. All right, so now we multiply each fraction that we see in the equation with x times x plus 20. So 392 all over x plus 20. It should be 20, not 0. Multiplied by x times x plus 20. All of that's going to equal 322 over x times x plus 20. Now we're going to get rid of our denominator. The x plus 20's cancel out. We're left with 392x. Then the x's cancel out. We're left with 322 times x plus 20. We're going to distribute out that 322. So we get 392x equals 322x. And 322 times 20 gives us 6440. All right. So we're going to minus the 322x over, and when you do, you get a 70x. That equals 6440. So we just add the x's together. And from there, if we divide by 70 on both sides, we get that x equals 92. So that x, we said, is the rate of the freight train, or the speed of the freight train. It's the same thing in this case. So that means the freight train has a rate of 92 miles per hour. And the passenger train, that has a rate of 20 more than the freight train, so 112 miles per hour. And that's going to be our answer. Okay? So from here, let's go on to problems 4, 5, and 6. So on 4, 5, and 6, we have this new equation. We're just told if you have two things, or two people in this case, that are doing the same work, and how long it takes them to do each work. If you add them to the 1 over the time that it takes to do the work together, you're going to get the time it takes them to do the work together. That's not really weird trying to explain it, because I think it's really weird to explain. I think it's just better if we go ahead and do an example. But I want to start on number 5, not number 4. I think the equation will make more sense if we start with number 5. So for number 5, we're told Amy can complete a task in 7 hours, and Jane can do it in 3 hours. How long will it take them to do it if they work together? So that's what I was trying to say. If Amy completes in 7 hours and Jane does it in 3 hours, we can use that equation to figure out how long it will take them to do the same job together. So remember, it's 1 over time 1 plus 1 over time 2 equals 1 over the combined time. So if Amy takes her 7 hours to do the work, that's going to be 1 over 7. And if it takes Jane 3 hours to do the work, that's going to be 1 over 3. The time 1 and the time 2. And if we add these together, we're going to get our x value here, which is the time it takes them to do the work together. So that's what the equation means. I think it makes a little more sense if we actually do a problem rather than me trying to explain it. All right, so we're going to go back the same way we did on problems 1, 2, and 3. We're going to find our LCD. And if you solve that for your LCD in this problem, you should get 21x. So that's our LCD. We're going to multiply each fraction by that 21x. So 1 over 7 times 21x plus 1 over 3 times 21x. It's going to equal 1 over x times 21x. So 21x divided by 7, that's going to give us a 3x. 21x divided by 3, that's 7x. And then here, the x's just cancel out. We're left with 21. Okay? So what we do here, we're just going to add like terms, and we're going to figure out our x value. 7x plus 3x is 10x. That equals 21. Or in other words, x equals 2.1. Or another way to say it is that it takes them 2.1 hours to do the job together. It takes them 2.1 hours to do the job together. All right? And now that we get number 5, we can go back to number 4, and we can try solving it together now. So for number 4, we're told Kevin can clean a large aquarium tank in 7 hours, but when Kevin and Laura work together, they can clean the tank in 4 hours. So we know the combined time is 4 hours, and we know Kevin's time is 7 hours. What we need to figure out now is going to ask us how long it takes Laura to clean the tank by herself. So we know that Kevin, his time is 7 hours, so it's going to be 1 over 7. So that plus Laura's time, which we don't know, so we're just going to call it x. That's going to give us our combined time of 4. Right, we're using our equation. The first one is Kevin. 1 over time 1, that's going to be Kevin's time. 1 over times 2, that's Laura's time. That equals our combined time, which is 4 hours, if we're looking at the equation. So we're going to do the same thing. We need to figure out our LCD. Our LCD in this problem, if you solved it out, is going to be 28x. Like I said, I'm not going to spend too much time trying to figure out the LCD. If you need help with that, go back to the previous video, and that should explain how to figure out your LCD. So we multiply each fraction by 28x. 28x divided by 7, that's going to give us a 4x. 28x all over x is going to give us a 28. And then over here, 28x divided by 7 is 7x. So we're going to minus the 4x over, we're going to add like terms and solve for x. Get 28 equals 3x, or that x equals 9.3. So that means Laura, it takes her 9.3 hours to clean the tank by herself. All right? So that's why I thought doing number 5 would be a little easier than doing number 4, so you see how to use the equation normally. So we have one last problem, number 6, or rather we have 2 more problems. We can do number 6 and then number 1 in the homework. So for number 6, we're told it takes Bob twice as long to clean the house as it takes Claire to clean the house. Together they finish cleaning the whole house in 3 hours. So we know their combined time is 3 hours. But we need to know how long it takes each one separately to finish the job. So we know Bob, it takes him twice as long as Claire. So if Claire is x, if her time is x, Bob's time is going to be 2x. So we're going to figure out our LCD. And our LCD in this problem is going to be, if we list out each individual factor, we have 2, x, and 3. Okay? So if we solve this out, our LCD is going to be 6x. So our LCD is 6x. So we're going to multiply each fraction by that 6x. I don't know why I didn't multiply it there. It's kind of rewrote it. 1 over 2x times 6x plus 1 over x times 6x equals 1 over 3 times 6x. These cancel out. We're left with 3. 1 over x divided by x. The x's cancel out. We're left with 6. And lastly here, 1 over 3 times 6. These cancel out to give us 2x. So 6 plus 3 is 9. That equals 2x. Or 9 over 2 equals x. So that our x value we said is Claire's time. So if you write up here in the top right corner, we'll say Claire, her time is 9 over 2, which is 4.5. So it takes her 4.5 hours to clean the whole house. And we said Bob takes twice as long. So if Claire's time was 4.5, Bob's is going to be 9. All right? So let's go on to number 1 on the homework. Okay, and now for number 1 on the homework. On number 1, we're told a boat which moves at 24 miles an hour in still water travels 6 miles downstream in the same amount of time that it takes to travel 4 miles upstream. All right, and what we're going to do here is we're going to set up an equation we're going to set up an equation that can be used to find the speed of the current. All right. So we know the speed of the boat when it's standing in still water, but we want to know the speed of the boat, the speed of the current in the water. Okay. So to figure that out, what we're going to do is we're going to be using the distance over time formula, or distance over rate formula. Sorry. So we know when the boat is traveling 6 miles downstream, it's going to equal the same amount of time that it takes the boat to travel 4 miles upstream. Only thing we need to do now is we need to figure out the rate for each one. What the rate will be when we're going downstream, and what the rate will be when we're going upstream. So we're going downstream, that means that we're actually going with the current. So we're going to be usually faster than the actual current. And the problem, we're told that we're going to be using R to equal the speed of the current. Okay? So if we know the boat can go 24 miles per hour by itself in still water, if we're going downstream or we're going with the current, the rate will be that 24 miles per hour plus the speed of the current. Because we're going with the current kind of pushes the boat with us, so we're increasing the rate of the boat. But if we're going upstream, that means that we're going to go against the current, so the speed of the boat will be, or rather the rate for going upstream will be the speed of the boat minus the speed of the current. Because we're kind of fighting against the current, so we're going slower than we usually would by however much the speed of the current is. Okay? So this is what our equation is going to be for number 1. So for number 1, what we need to do now that we have what our equation is going to be is we need to figure out our least common denominator. And if we figure out our least common denominator, we're going to get 24 plus r times 24 minus r. It's a little ugly, it's a little cramped up, but I don't have much room. But that's what your LCD should be. And once you have your LCD, what you're going to do is you're going to multiply it with each fraction. So we have 6 all over 24 plus r times our LCD, which is 24 plus r times 24 minus r. So I'm messing you rewrite it. 24 minus r. And our other fraction, which is 4 all over 24 minus r, we're going to multiply that with our LCD as well. Kind of broke up the equation really quick. So you get my 2 fractions, and I get 24 minus r. And if I solve each one out, for the top one, 6 over 24 plus r, the 24 plus r's cancel out. We're left with 6 times 24 minus r. And for the bottom, 4 all over 24 minus r. If we simplify it and we get rid of this 24 minus r in the top and bottom, we're left with 4 times 24 plus r. Okay? So these are 2 fractions. These are 2 new fractions, and we're saying them equal to each other. So we're going to ignore number 2. We're not going to work that in this video anyway. But we're going to continue our work down below. So we're going to set each fraction equal to each other. 6 times 24 minus r equals 4 times 24 plus r. Because that's how we originally had it, we had each fraction equal to each other. I just broke it down to get what the reduced version of each fraction would be. So that's what we get. And now we're going to distribute out the 6 and the 4. 6 times 24 gives us 144. And that's going to be minus 6r. And that's going to equal 4 times 24, which is 96, plus 4r. We're going to add like terms. So I'm going to add the 6r over, minus the 96. And I get that 48 equals 10r. Or I get that 4.8 equals r. So the speed of the current is 4.8 miles per hour. So the current is 4.8 miles per hour. And that's how you do number 1 when you talk about upstream versus downstream. All right, well, that's the end of the video, guys. Hopefully that was helpful. And that's about it.